All right, let's look at another kind of pro tip for balancing equations. And this deals with um, how we can handle polyatomic ions. Now, as long as the polyatomic ion is the same on the reactant side and product side, you can treat it as a unit. So like, for example, if there's a sulfate on the left and a sulfate on the right, you can treat them as one unit and balance them like that. You don't have to look at it, okay, well, I got to balance the S's, I got to balance the O's. I'm going to keep the SO4 together. Okay, so let's show this in practice. So we have aluminum bromide reacts with potassium sulfate to form aluminum sulfate and potassium bromide. So I got my reactants over here, and these are going to be my products. You say, I don't see any formulas there. Well, we've talked pretty extensively about how to name and how to write formulas for compounds. Okay, but let's kind of, I'll help you out a little bit with this one. Aluminum generally always has a +3 charge. Bromide always has a minus charge. So aluminum bromide, the formula will be AlBr3. Potassium sulfate. Potassium is K, has a charge of +1, always. Sulfate is a polyatomic ion, SO4 2 minus. So the formula be K2SO4. Aluminum sulfate. So again, aluminum is always +3. Sulfate is SO4 -2. So we have Al2SO4, 3. And potassium bromide, well, K is always +1, bromide is always -1, so they cancel out. Now, I want you to notice something important here. There is sulfate on the left and sulfate on the right. So I can treat them as a unit, not individual sulfur atoms and oxygen atoms. I can only do this as long as it's the same ion. If sulfate had changed to sulfite for whatever reason, then I cannot use this tactic. And so let's outline all of our atoms here. We have aluminum, we have bromine, we got potassium, and I'm going to keep sulfate together. Let's just outline how many we have to start and finish. So we have 1 aluminum on the left, 2 on the right. How many bromines do I have? I got 3 on the left and 1 on the right. I have 2 potassiums on the left and 1 on the right. And then with sulfate, I have 1 on the left and I have 3 on the right. All right, so I'll go back to like pro tip number 1, pick something that only appears once on each side. That's pretty much anything there. So let's just kind of start with the aluminum. I need to have 2 aluminums on the left to match the 2 on the right. Now you're looking and I say, well, wow, you just really threw off the bromines. Okay, well, that's fine. I have 6 bromines on the left. Oops. So I'm going to put 6 bromines on the right. Okay, great. But I drastically threw off the potassiums because I have now 6 potassiums on the right. So how do I get that on the left? Well, if each of these provides 2, if I put a coefficient of 3, then 3 molecules of potassium sulfate will have 6 potassiums in it. And if you look at what I've done here, by putting a coefficient of 3 there, that gives me 6 potassiums, but it also gives me 3 sulfates. And I already have 3 on the product side. So I just inadvertently balanced my equation by doing that. Right? And I encourage you again, go through it, double check your answer, make sure you have the same number of atoms on both sides. All right, so let's get some more practice here. So write a balanced equation for the reaction of molecular nitrogen and oxygen. So we got a reactant here to form, that's like where our reaction arrow is going to be, and dinitrogen pentoxide will be our product. Okay, so let's put this down. So we got nitrogen and oxygen. It's going to make dinitrogen pentoxide. So let's outline all of our atoms. We got nitrogen and oxygen. So on the left, there are 2 nitrogens. On the right, there are 2. For oxygens, there's 2 on the left and 5 on the right. Okay, well, nitrogen's already balanced. Um, how do I balance those oxygens though? Because if I go and I put a 5 here, that's going to give me 10 oxygens. So this is the case where I'm going to temporarily use a fraction, because if I do 5 over 2 and then multiply it by 2, that equals 5. But I can't leave it like that. So I'm going to multiply all of the coefficients by 2. So now my new balanced equation looks like this. 2N2 plus 5O2 produces 2N2O5. Right, and if we kind of double check our answer here, we got 4 nitrogens, 10 oxygens on the left, 4 nitrogens, 10 oxygens on the right. All right, let's look at the next one. What I recommend you do is pause the video, try to work through this problem on your own before I go through it on the video. All right, so hopefully you've paused it, you've looked at it, you've got all your correct equations. Again, on an assessment or homework, you probably aren't going to get the formulas written out for you. So make sure you know how to know your nomenclature. So we're going to take magnesium chloride. And notice it says aqueous solution. So that's why I'm putting AQ there. And sodium hydroxide. We're going to react to produce magnesium hydroxide. And it says solid, so I'll put an S there. And aqueous sodium chloride. Now, one thing I'm going to note before we start, we got some polyatomic ions here. We got hydroxide. And it's also hydroxide on the product side. So I'm going to treat hydroxide as a unit. So I got my magnesium, chlorine, sodium, and hydroxide. I'm not going to treat it as oxygen and hydrogen. I'm going to treat them as a unit. So I got 1 magnesium on each side. I got 2 chlorines on the left and 1 on the right, so I got to balance that. I have 1 sodium on both sides. And I have 1 hydroxide on the left and 2 on the right. So let's balance those chlorines first. So if I put two chlorines over here. Switch colors. That will balance out my chlorines. Which like, well, you just threw off your sodiums. Yeah, I did. So let's fix that. Because I have two on the right now. I need to put two on the left. Great. That takes care of that. And notice what I inadvertently did here. By putting a coefficient of 2 in front of the sodium, I'm also saying I now have two hydroxides on the left. Well, I had two on the right, and everything is magically balanced. Again, let's check that real quick. One magnesium on the left, one magnesium on the right, two chlorines on the left, two chlorines on the right, two sodiums on the left, two sodiums on the right, and two hydroxides on the left, two hydroxides on the right. Okay, let's do a few more practice problems here. So solid sodium chloride is added to aqueous sulfuric acid, and then hydrogen chloride gas and aqueous sodium sulfate are produced. Okay, so when these things are added, those are reactants, these are going to be our products. So again, pause the video, try to draw out the non-balanced equation, or actually work through the whole problem, try to balance it as well. And then we'll come back. All right, so I'm going to take sodium chloride, react it with sulfuric acid, and that produces hydrogen chloride gas. And sodium sulfate. Now notice something important here. There's sulfate on the left, there's sulfate on the right. So I'm going to treat them as a unit, not like sulfur and oxygens. So let's outline what we need to do here. So we got sodium, chlorine, H's, and sulfate. So with sodium, we got 1 and 2, 1 on the left, 2 on the right. Chlorine's 1 and 1. H's are 2 and 1, and sulfate is 1 and 1. All right, so let's pick something to balance first. Everything only appears once on each side, so I can pick anything. So let's just start with the sodiums. So I have 2 on the right, and so I'm going to put 2 on the left with a coefficient. Now that kind of throws my chlorines off. I was balanced with chlorines, and now I just threw them off because I have 2 on the left now. So I'm going to go over here and put 2 on the right. Now notice what this does, or what this does, it kind of helps me out here because I ended up putting 2 hydrogens on the right that balanced out with my 2 hydrogens on the left. And then I never messed with sulfate. Sulfate was always 1 and 1, and it's still 1 and 1. And so now I have a balanced equation. All right, and finally, let's do one more. So, so pause the video, see if you can come up with the balanced equation for this, and then I will do it with you. Okay, so we're going to start with barium nitrate. And that leads to the decomposition, leads to the formation of barium oxide plus nitrogen plus oxygen. Remember, nitrogen and oxygen occur as diatomic elements, so that's why they are N2 and O2. And notice something else important here. I'm starting with the polyatomic ion, but I don't end with that. So I cannot use nitrate as a unit. I'm going to treat nitrogens and oxygens individually. So the atoms I have to outline are barium, nitrogen, and oxygen. All right, well, bariums are pretty good. I got 1 and 1, so I'm happy with that. How about nitrogens? Well, this um, subscript of 2 means I have 2 nitrates. So I got 2 nitrogens on the left and 2 nitrogens on the right. That's great. Now, how about oxygens? So again, that subscript of 2 means 2 nitrates, which is 6 oxygens in those nitrates. And then I have 3 oxygens on the right. Okay, notice here, 1 oxygen there, 2 oxygens there. Now, the way I'm going to balance the oxygens here is I'm going to balance the O2. Why am I focusing on the O2? Because if I try to balance the oxygens in barium oxide, I'm going to throw off the number of bariums. And then I got to go back to the left. And then that's going to balance, it's going to throw off my nitrogens. So it's much easier to balance the O2 that's by itself. And I need 5 more oxygens. Or I'm sorry, I need 3 more oxygens to balance this out. But I can't just put a 3 there because that's going to give me too many. But if I put 5 over 2, notice if I do 5 over 2 times 2, that's like saying 5 oxygen atoms. That would get me 6 oxygen atoms on both sides. But I can't leave a fraction there. So I'm going to multiply all the coefficients by 2. So 2 barium nitrates makes 2 barium oxides, 2 nitrogens, and 5 oxygens. And if I go to check this, I got 2 bariums on the left, 2 bariums on the right. With nitrogens, so each nitrate gives me 2 nitrogens, but I have a coefficient of 2. So that's 4 nitrogens. I have 12 oxygens because each nitrate gives me 6 oxygens, and I have 2 barium nitrates. So that's 12 oxygens. On the right, I have 4 nitrogens and a total of 12 oxygens. So again, like a lot of other things I recommend, this is only going to come with practice and a lot of repetition. So I highly recommend get into your textbook, do a lot of the practice problems that are in your textbook as well.